Hi students, now we will talk about vector components and how to use these components in some computations. Let us take this example. If we have a vector v and a vector u, the vector v is starting from point 0, 0 and ends at this point S, which is 3 in x direction and 4 in y direction. So this vector has component 3 in x direction and 4 in in y direction, and it's beginning from 0, 0. Okay. Also, vector u starts from G, ends with H. G is at -2 in x direction and 2 in y direction, but its end point at -4 in x direction and 4 in y direction. Okay, now we need to know the x component and the y component of each vector. We don't know how much the length of the vector v, and we don't know the angle theta for v. Okay, we don't know also the angle for the vector u. Let us start with vector v. Okay, vx, the component of vector v in x direction. We need to take the last or the end position in x direction, which is 3. The initial position, which is 0. The difference between them is 3 minus 0, which is 3 units. Maybe it is length, maybe it is force, maybe it is velocity, acceleration, or anything. It is just unit for this vector. What is the So now the x component is 3 minus x, which is the x length for the x component for the vector v. What about the y component? It is 4 minus 0. So the length of the y component for vector v is 4 minus 0, which is 4. Okay, what about the vector u? For the x component for vector u, initial point is G, final point or end point is H. So the length of x component for vector u is the end point minus the initial point in x direction, which is -4 minus -2. -4 minus -2. This length, because it is in the x minus direction, it will be in negative sign. -4 to -2. We will keep the minus sign here. What about the length of the y component for vector u? It is 4 minus 2. It is also 2. Now look at these squares. H square is a half unit. 2 of them is 1 unit, 2 units, 3 units, and also here it is 1 unit, 2 units in negative x direction, and 2 units in positive y direction. Now if we need to write the vector x and the vector y, we need just to write it like this, in this way. V as a vector is equal to v in x direction, which is vx component, and plus vy, which is in y direction. We will learn how to write them later, but I need you now to know that the vector v, for example, is a 3 units in x direction and 4 units in positive y direction. But the vector u is ux in x direction and plus uy in y direction. Ux, we find it is -2 in x direction plus 2 in y direction. Okay, we can drag any one of these vectors, but we need to keep its direction and its length. It's easy to, for example, to draw the vector u in from here to here, since it has its angle, its direction theta u, and length. It is 2 units in negative x direction and 2 units in positive y direction. What if we need to add them together? It is easy. We need just to drag the vector u and put it at the end of, this is u. So this is the addition process, vector u plus vector v. It is okay to use any one of them at the beginning. So it is the same to say u plus v is equal to v plus u, as we see in the previous slides. We will change the scale. It is easy to change the scale, but just we need to keep the length of the vector and the direction. We can keep them by keep the components the same length. For example, as we see here, Vx is 3 units, Vy is 4 units. Okay, look at this vector. It is 1, 2, 3. This is Vx. 1, 2, 3, 4. It is Vy. So this is the vector V. This is also the vector u, because it is negative 2 units in x direction and positive 2 units in y direction. This is u. It is the same. Just I change the scale. We can do it. And I suppose, and I named the resultant vector, if I add them together, I name it as S. So S is equal to V plus U. If you see here, S is 1 unit in x direction and 6 units in y direction. So S is equal to 1 unit in x direction plus 6 units in y direction. Okay. Now we have the two vectors. V is 3 units in x direction plus 4 units in y direction, and U is -2 in x direction and +2 in y direction. This is the vectors again. Keep this graph in your mind. And from the graph, we found that S is equal to 1 in x direction plus 6 in y direction. It is easy to find that because S is equal to V plus U. And S contains two, or composed from 2 components, which is Sx and plus Sy. V is equal Vx plus Vy. U is equal Vux plus Uy. We need just to do this process. Sx is equal to Vx plus Ux. Also, if we have any other vectors, it is easy to do it. So Sx is equal to Vx plus Ux. Sy is equal to Vy plus Uy. So, as we see here, Sx 3, Ux -2, it will be 1. Sy, as we see here, Sy plus Uy, which is 6 units. Okay, this is the vector S. What if we need to multiply one of these vectors by a number? What if we need to find 5v minus 3u? We see from before that we can multiply a vector by a scalar, by a number. This will give us the same vector but with different length. So 5v is equal to 5 multiplied by vx plus vy minus 3u, 3, the minus is minus, 3 multiplied by the vector u, which is ux plus uy. Do it here. 5 will go inside these parentheses and brackets, and this 3 also. Vx is 3, as we know from before. Vy is 4. We just need to multiply 5 by 3 plus 5 multiplied by 4 minus, which is the same minus, this minus the same, 3 multiplied by ux, which is minus 2 in x direction, plus 3 multiplied by 2 in y direction. So we have 15 in x direction plus 20 in y direction, minus, with this minus it will be positive sign, 6 in x direction, minus with positive it will be negative sign, minus 6 in y direction. So we need just to add the x component together, which is 21, and the y components together, which is 14. So this vector, new vector, we multiplied 5v minus 3u is equal to 21 in x direction plus 14 in y direction. Okay, now what if I need to deal with the vector v? This is the vector v. I need to find the length and I need to find the angle. It is easy. The vector v here is equal to 3 in x direction plus 4 in y direction. So vx is 3, vy is 4. If I need to find this vector v, I need to find its length. I have the x component 3, the y component is 4. I have right triangle. I can use the Pythagorean theorem. V, the length of v, is equal to vx squared plus vy squared. Vx 3 squared plus 4 squared, it is 9 plus 16. It will be the length, it will be the root of 25, which is 5 units. What if I need to find the angle theta? If I find theta u v, then I can find the direction of v. Again, this direction is x positive or east. This is y or north. I can't say in physics just the vector v is northeast. I need to say the angle to be more accurate. Okay, I know that tan theta, this is theta, is equal to vy, this is vy, this is vx, this is theta, this is the length of v. I know that tan theta is equal to vy over vx. Sine theta is equal to vy over v. Cosine theta is vx over v. I know the lengths. This is 3, 4, and 5. So I can find any one of them. Tan theta is equal to 4 over 3, which is 0.75. Cosine theta is equal to 3 over 5. Sine theta is 4/5. What is theta? It's the arc tan or the arc cosine or the arc sine, which is tan inverse or cosine inverse or sine inverse for this argument. So theta is tan inverse for 4/3, which is 53.13 degree. If I use the cosine, it is the same angle. If I use the sine, it is the same angle. But the fastest way is just to use tan, because I have Vx and Vy. I don't need to find the length of V. Before I find the length of V, I can find the angle for this direction, for this vector. The same way you can do it for the vector u. You can find its length and its direction by using the arctan or tan inverse, and the same for the vector s. I find you can do it. The length of u is 2.3883, and the length of s is almost 6. Okay, and you can find the direction of each one of them. We have here 2 examples. I will not solve them now. You need to try them. I will try them with you in the class. We have the vector A and the vector B. We have the components of each one of them, and we have the vector R. Just I need to find the length of R and the direction, which is theta, and the components of R. By the way, you can find also the length of A and B for these 2 examples. Also, we can use this example. We can do it also. We have vector A, B, C, and D. All together, they give me the resultant vector, which is R. So R is equal to A plus B plus C plus D. You need to know that Rx is equal to the x component for each vector, and the y component of R is equal to y component for each vector. You need just to fill this table and the length of, and also after that you can use also the Pythagorean theorem to find the length of R and the direction of R. Try that by yourself. It will be easy. Thank you.